Good morning everyone. I am Tanushri Dalai from Civil Engineering branch. So in the last class we discussed about the shear force and bending moment calculation of cantilever beam having point load and also having UDL. So today we will discuss some numericals regarding the point loads acting on a cantilever beam and solve the problem, calculate the shear force and bending moment, and then we will draw the shear force diagram and bending moment diagram of the beam. So now let's see what is the question of beam. So your question is draw the SFD, which means shear force diagram, and BMD, which means bending moment diagram of cantilever beam. So your beam is given as, here it is a cantilever beam, and on that beam 3 point loads are there. That is, at the free end 3 kN is acting, at point C 3 kN is acting, then another point load which is 2 kN, and the distance is given. So now we have to calculate the shear force calculation, and what are the shear force and bending moment. So let's see the calculation part. So in case of solution part for this problem, we need to first draw the beam section with the loading parts. Then we need to draw the dotted line towards the downward direction at each point which is given in the question, like at point A, at point C, at point D, and last, which is B point, we need to draw vertically downward dotted lines as the reference line to draw the shear force and bending moment diagram. So first of all, you need to draw the diagram part. Then calculate the calculation of shear force and bending moment. So first of all, I told you at the derivation part, in case of cantilever beam, we need to calculate from the right side of the section to the left side of the section. So here, if we apply this condition, then our calculation should be from A to B. So in that way, we have to calculate. So the first shear force is from the right side, which is point A. So your shear force at A is 3 kN. Why? Because at the point A, only one load is there, which is 3 kN. Okay. So here also, we take a section and assume that the section will be somehow here. Okay. So that according to the section, your load is right side of the section and it is downward in direction. So that's why your shear force value should be in positive. Hence, your shear force at point is 3 kN. Then next is shear force up to point C. That means the shear force from A to up to C, from A up to C. So while we consider the shear force from A up to C, we need to verify whether there is another loading is provided or not. So you can see from A to C, there is only one load is there, which is 3 kilonewton, except that no loading system is there. So that we can say the shear force at A will be continuous to the point C, that means up to point C. So that the shear force up to point C is unchanged, that is 3 kilonewton, which we already got from the shear force at point A. So the value should be 3 kilonewton at which point? The shear force up to point C. Okay. So now comes to the shear force at point C. So while we have to calculate the shear force at point C, we need to consider the loading at point C. So you can see at point C, the loading is 3 kilonewton. So we need to add the shear force of up to point C with the shear force or the loading system at point C. So we got the value shear force up to point C, which is 3 kilonewton, and shear force at point C is, or load system at point C is 3 kilonewton. So as a whole, we need to add these two forces over here. So the shear force up to point C is your 3 kilonewton, and shear force at point C should be 3 plus 3, which equal to 6. That means 3 kilonewton, which is this load, and another 3 kilonewton, which is this load. So we just add these two values. Then we got the value of shear force at point C, which is 6 kilonewton. Then similarly, shear force up to point D. So while we consider up to point D, that means we need to see what are the values or what are the loads acting at the right side of the section. So you can see here one load is there and two load is there if we consider up to point D, not at point D, only up to point D. So two loads are there, so we just add these two loads, which is 3 kilonewton plus 3 kilonewton. So the shear force up to point D, the value should be 6 kilonewton. So you can see the shear force up to point D is 6 kilonewton. Then comes to shear force at point D. So the value of shear force at point D is 3 plus 3 plus 2, which is 8 kilonewton. So whenever you calculate the shear force at point D, we need to consider the load at point D. So we got the value shear force up to point D is 6 kilonewton, and the force or the load at point D is 2 kilonewton. So we have to add the shear force up to point D value with the force at point D, which is 2 kilonewton. So 6 plus 2, which is 8 kilonewton. Okay. So now comes to the last part of the section, which is at the fixed end support. So if we consider this point So we need to see at the right side of the section how many loads are there. So you see here 3 loads are there. So just sum this all the loads, and that's the value of the point B. That means in between D and B only no load is there, so that we considered that the shear force of the D or shear force at point D will continue towards the point B because there no loading condition in between D and B. So the shear force at point D is the value of shear force at point B, which is 8 kN. So now we have to draw the shear force diagram according to these values. So first point at point A, we got the value 3 kN. So before that, we need to draw a reference line, which is, you can see here, this line is your reference line, and your shear force calculation, all the values are in positive because these all the points we consider at the right side of the section and the direction of the loading is downward, so that we will take the value as positive. So at the first point at point A, the value of shear force is 3 kN. So we put a point over here. Then it is continue up to C as 3 kN, and at point C the value of shear force is 6 kN. So we detect a point here. Then this 6 kN again continue up to point D, which is here. Then at point D the shear force value is 8 kN, which is over here, and this 8 kN again continue towards the end of the beam, that is at the fixed end support. So we just need to join all these points, and then we join the diagrams with the reference line. Hence, we got the diagram of the shear force having all these shear force values. So this is all about the shear force calculation and shear force diagram of this cantilever beam. We will discuss the bending moment calculation and bending moment diagram in the next class. Thank you.